the particular relationship I want to show you is the binomial theorem, okay? I hope you're reasonably convinced, like we built this thing by going downwards, didn't we? Okay? To get this, we look above and go further, okay? But I think you're probably convinced that there's got to be relationships along rows as well, okay? And we already saw like factor to 7, factor to 5, etc. So for instance, let's just have a look at this guy, and you're going to need to write this one with me because otherwise you will not be able to follow. Let's look at these 6 numbers, okay? 1, 5, 10, 10, 5, 1. Okay, now those are what the numbers are. We've already introduced some notation to let us write these in proportion to the binomial coefficients, right? And then we introduce these brackets, right? So how do I rewrite this line in binomial notation? I can either do the C's or I can do the brackets. I'm going to do the brackets, if that's okay. It's the 5th row, right? 5th row. So it should be 5, 0. Good. Then 5, 1, 5, 2, 5, 3. You get the idea. Whoops. Okay, good. Now I'm suggesting, based on this, seeing this, that there must be some kind of relationship between these numbers, like the numbers of an individual row. Look, they arrange themselves into patterns. They cannot just be independent, right? So what is the relationship? Well, let's have a look at this. How do you get from one number to another? Okay, you can think about it a couple of ways, I suppose. You could think about it in terms of adding. You add 4 to go across, you add 5, you add 0, etc. Okay. But we just looked at factorial notation because it suggests that even though it's built by addition, you look at these rows, multiplication is in there, hiding. Okay. So what do I multiply by as I go across here? From 1 to 5, not hard. Multiply by 5. Okay, 5 to 10. I multiply by 2. Okay, by 1, same number. And then, what do I multiply by here? A half, good. And then a 5th. Okay, Now, there's something going on here. Now, you have the advantage of knowing that we've done factorial notation specifically so that we can understand this. So there is a factorial hiding in here. Actually, there are 3. But where are they? And how can we make this a little more obvious? Okay, 5. I'm going to write it. I'm going to write all these same factors, just in a different way. I'm going to write it as 5 on 1. 5 on 1. It's a fraction. I'm writing it like that because I see that this is a fraction, right? It's the reciprocal. Okay. Now, I could write this as 2, but I'm looking for a factorial. How else can I write it? I think I can write it. Remember, I'm going to get fractions in the end, right? 2 times 1 is a factorial. It's not a useful one. It doesn't match the pattern. I think 4 on 2 is a better way to write it. Okay? Because 4 on 2 is 2, right? What do you think I should put in the middle? I think that's 3 on 3. And I think that's 2 on 4. Hold on. Now, I said there were 3 factorials hiding in there. 2 of them are obvious, but 1 is hidden, okay? And it's kind of hard to see because what we're looking at right now, you have to multiply by all of these and then you get to this one. But let's just consider them individually, okay? 5, C0, okay? By definition, right, is 1, okay? To get to 5C1, you take this, but you multiply it by 5 on 1. 1 times 5 on 1, that's, yeah, okay? Now, as you build, can you see what's happening? This is going to be 5 times 4 on the top. Let's just finish. 1 times 2 on the bottom, right? Now look. This does not have 2 factorials in it. You need another one to make it work. I can't write that this is 5 factorial on 2 factorial, because it's not. You've just spent half an hour doing factorial notation. How can we make it right? I've got to, not quite minus. It's all about multiplication, right? I need to divide. Do you see what I did? This is 5 factorial on 3 factorial, but it goes on the bottom. Okay. All right, next one over. What is it? It's going to be 5 by 4 by 3, 1 by 2 by 3. I'm in the middle now. Okay, how do I write this thing? It's not 5 factorial on 3 factorial. I have to divide by 2 factorial because there's missing terms up here. Oh, look. Of course they're the same. They're the same. Alright, hold on. Not done yet. We've got... How do I write it? How do I write it in factorials? There's a 5 factorial on the top. There's a 4 factorial on the bottom, but what do I compensate with?
1.
A 1 factorial. Because you're like, actually, there's a times 1 in there. Alright, now, one last one. 5. Now, you don't need me to write this out. It's 5 factorial on 5 factorial, isn't it? But you've seen enough to know there's actually a 3rd factorial in here. What is it? It's 0 factorial, right? Of course it is. So therefore, okay, you ready? This is just for one row. I want this, okay? This is where it culminates. Where does the n appear? Have a look at the pattern. It's always on the top, every time. Okay? Now there are 2 factorials on the bottom, right? What are the 2 factorials? Look, here I had 3. There's a 3 factorial and a 2 factorial. Here's a 4. I have a 4 factorial and a 1 factorial. So at least you're going to get an r factorial. I always see that one. What's the other one? And that is the binomial theorem.